We realized, the energy transition is missing a key piece of the puzzle, and that's long-duration energy storage. We need a lot more electricity because the consumption of electricity is increasing. We have electrification happening across so many areas, and how are we going to deal with that? We are using steel, water, and air, and we are completely free from critical materials. We believe we're going to be living in a future that we can harness as much as we can from what we have.
Welcome, Monica. Thanks for joining us. So you guys are doing long-term energy storage with compressed air.
Yes.
But before we dive into your technology, I thought you have an interesting background. Let's just start there. Tell me a little bit about yourself and how on earth you ended up doing what you're doing now.
Yeah, so thank you for being here. I'm originally from Brazil, and I chose architecture as the path to start. And the reason was I wanted to multiply my work. So I had an experience in England where I lived there for 1 year, and I basically experienced parks and museums open to the public, and it was man-made. And that experience actually made me realize, like coming from Brazil in a place where beach is the open space and it's free, but it's nature-based. And I thought like, okay, we have the power to create something that is going to be meaningful for a lot of people. So I chose architecture because I wanted to basically create public buildings, museums that would bring culture, well-being to a lot of people. And I did architecture and urban planning. And then I felt my studies were very focused on the rational, and I wanted a lot of the emotions and subjective part of building something. So I moved to Italy. I worked there as an architect and urban planner. But then I went there to study like the conceptual part and what is the meaning of the things that we build. And I started working projects for the car industry, and eventually I moved to Germany to work in the car industry, creating concepts and thinking of futures that we would be living and creating products for that.
Cool. So you're doing concept design initially, huh?
Yes.
Oh, that's a lot of fun.
Yeah, so I did that for 18 years. I worked first for General Motors and Kia. And a lot of the cars that I worked on are on the streets in many markets. So it's super exciting. I got the scale of what I wanted to do, but I always felt there is the impact missing. And at one point, I felt also like my learning curve had plateaued, and I wanted to accelerate that. And I joined the Venture Builder program called Carbon 13. And there you can come as an individual with or without an idea. And the reason I joined it is because of the mission it has. And the mission is create ventures that, when at scale, with at least offsetting 10 million tons of carbon equivalent when at scale. So I felt, okay, this has the mission that I want, and probably the peer group that are motivated and committed enough to do that. So there I joined the program. I met my two co-founders, and we set ourselves to solve the root problem. And we looked at several things of where we could multiply most our efforts. And we realized, the energy transition is missing a key puzzle, a key piece of the puzzle, and that's long-duration energy storage. And so the technology came from one of our co-founders, who is a scientist, Denis. He was, he did whole academic career in the US as an astrophysicist, experimental astrophysicist. And he was in Antarctica for a full year, being the solo scientist responsible for large telescopes observing the early universe. And he saw firsthand the effects of climate change. And he then felt compelled to apply his scientific knowledge into something. So he joined startups. He moved back to France. He worked in a nuclear fusion startup. And there he met Simon. Simon is a mechanical engineer. And he, at one point, he worked in big corporations, so Airbus, Atlas Copco. And he wanted also to have this entrepreneurial experience. So he did an MBA. He met also physicists. He helped to build a nuclear fusion startup. He was CFO and board member. And the two realized nuclear fusion is a great technology, but we need a couple of decades to get there.
That's what they keep saying, right?
Yeah.
30 years away.
30 years away. And it's like, we don't have 30 years. We want to make impact shorter. And they also joined the Venture Builder program. And eventually we came together and we felt we are a good complementary team.
Okay, so you have an astrophysicist, a mechanical engineer, and a conceptual car designer / urban planner / architect.
Yes.
And you guys fell into compressed air energy storage. Like how?
Yeah. So so compressed air energy storage came from Denis. So he's a physicist and he looked at the solution. So we did actually analysis of what could be things that we would work on.
So you started with a matrix of, you didn't have a moment of inspiration. You actually objectively were looking at the table of like,
Yes.
okay, where should we start?
Yeah, where should we start? Where we can better use our skills and where can we get in a big, like solving a big problem with the skills we have. And Denis did a very big deep dive in potential technologies. We also looked at carbon capture and things on the ocean, but eventually we said, okay, there is one core thing, which is the energy that enables so much more. So what are the technologies that we have for longer durations? And we realize we have some solutions, but there are limitations. Mm-hmm. So what we are seeing today is that we have lithium batteries that are cost competitive to a certain amount of durations. Beyond that, it gets very expensive. And the technology that we actually use most today for long duration energy storage is pumped hydro. And pumped hydro is like two lakes, one at the bottom, one at the top. You have electricity, you pump it up, and then when you need electricity, you release the water, rotates a turbine, generates electricity. But these are things that have been already explored for so many years, and we lack the places to scale that.
Geographically, you mean?
Geographically, but also like many of the sites that are available have been already explored.
Right.
So we need a lot more electricity because the consumption of electricity is increasing. We have electrification happening across so many areas. And how are we going to deal with that? So we looked at, okay, we started from the point like it would be great to have the pumped hydro principle, but with something that can still scale. And that's where we started looking, okay, instead of moving water with gravity, then you're like, okay, we can move it with pressure. Mm-hmm. And we looked at compressed air, and we've seen that there have been compressed air facilities. Actually, the first one is Honthof in Germany, built in 1978, but with very low efficiency and still dependent on gas. And the reason is because when you, perhaps I can explain a bit how the technology works.
I was just going to say, this is probably your time to dive into all of the thermodynamic issues which come with pressurizing gas to a really high pressure, right?
Yeah. So what we do, basically, we use electricity from renewables, and we power a motor that pumps water. And we have vertical cylinders that, as the water goes up, it traps the air at the top and compresses the air. When it reaches a certain pressure, we store it. And then when you need electricity, you release the air pushes the water back and rotates the turbine. So instead of using gravity, we are using the pressurized air to move water and rotate the turbine. Now, the challenge with that is and what we've seen that it was being used is when, for example, in this compressed air in Honthof, when you compress, you generate heat, and they let the heat release into the atmosphere.
That's just waste heat, huh?
Yes. Mm-hmm. And then when you expand it, you generate cold because the molecules go apart from each other and they get cold. And if you don't cool that down, it will freeze the water and
freeze all your pumps, break all your equipment.
Exactly. Yeah. So they use gas to reheat the air, which lowers your efficiency. You're still dependent on gas and you emit CO2. So we're like, okay, there must be a way to do that. And from Denis being a physicist and heat being compressed air, compressing air is a with the heat is a thermodynamic cycle. So he's like, okay, I will build something that can manage this heat efficiently so that we can keep the temperature of the process nearly constant as much as possible. So this is how we set ourselves to do it.
Yeah. Can you maybe also dive into one of the other challenges I read about with the older school way of doing compressed air storage is the scale and the fact that it's often done underground to avoid high pressure units being stored above ground because, of course, you're pressurizing to enormous pressures. So can you just paint a picture of how that used to work and how you guys are sort of trying to flip that on its head?
Yes. So we actually, so we have, depending on the capacity, like how much power we can store above ground or underground. So above ground, we actually not going to that high pressure. And the reason we don't want to go to high pressure, very high pressure, is because we want to use as much off-the-shelf components as possible. And if you go to higher pressure, you need special valves, thicker materials, and this increases the cost of the system a lot. And by doing this process isothermally, it means that we are never letting it go to high temperatures and not higher pressure. And the pressure we are targeting is between 2 and 300 bar. And what pressure is that? It's actually not that much because it's something that actually we are very much used to. Like if people go scuba diving, that's the pressure usually people carry on their bodies for quite some time under the water.
In a block of aluminium on their back.
Yes.
Yeah.
So that is the pressure that we are aiming for. And we are not planning to go like to hydrogen pressures that is 700 to 1,000 bars.
Cool. There's also this big difference, I guess, between grid scale stuff and one of the other projects. You guys are also looking at above ground modular. So you have these two avenues. I don't know how far you're down each avenue, obviously.
Yeah.
How do you think about these two different approaches, which is like really big civic infrastructure projects, which take super long, versus what a lot of smaller renewable energy companies are focused on, which is just iterating through smaller scale projects, but which could be modular, which means they can scale by just making 100 of a small thing and getting better each time.
Yeah.
Do you guys have an approach for this? Or?
Yeah. So our goal, in order to be able to really decarbonize the energy sector, is reach the grid scale. Okay. But we chose not to go directly to the grid scale because testing a new technology in such a big scale would mean like you have a lot of capex. And we decided to de-risk the technology doing in between steps. So we started, okay, we're going to work on a 100 kilowatt system in order to then after scale to the megawatt scale. And we realized there is actually quite a lot of interest on this 100 kilowatts. And that is consumers that have generation and also consume. And usually they generate more than they consume. And they then have to, if they don't store, they actually have to buy electricity at peak points for very high price. So they are interested in storing the excess, and instead of paying high costs from the electricity from the grid, they use what they stored. So basically, we realized there is actually demand for that. And we have discussions with 10 interested early adopters to have that, which we plan to deploy in 2028. And then we are already starting conversation with the grid scale, because those are big utility companies and large energy consumers. So these are big companies that, it's a much longer process to find the right fit and understand the exact needs they have. So we started early conversations with them, and the goal is to get long-term agreements with them to have like recurring guaranteed revenues.
Right. And so, I mean, you've lined up what sounds like a pretty cool pipeline of projects. Are you already at the point where you've de-risked the technology and the unit economics that you can start rolling out? Or are you still, is it like the technology is still being refined? So I guess where on this level of completion are you at before we just start seeing this stuff all over Europe, all the world?
So we are in the lab at this moment, and we done in 1 year quite a lot of progress. So in this 1 year, last year, we did a lot of hardware development. So in the lab, we created a test bench where we validated the isothermal process. So we managed the temperature and we proved that. Then we built a prototype where we validated the compression, the storage, and the expansion with a lower pressure and lower power. And this is already working. We set ourselves to reach by April, and we finished this April, May, and we just finished this 2 weeks ago.
Cool, well done.
Yeah, so we have this very cool piece of hardware in the lab running. And now we are fundraising to build the 100 kilowatts. So we started already with the engineering, and we are running simulations on these 100 kilowatts. And we now in order to leave the lab, be fundraising, we need more resources to be able to do that jump.
Can you just paint the picture a bit more, maybe, of what this 100 kilowatts unit is going to actually look like? How big is this in terms of scale? How long does it take to build? Are you going to build it on site? Is it like a bunch of small stuff you make in a factory and just ship to anywhere? How does this actually look?
Yeah, so the footprint of it, you can think of like a 140-foot container for the power unit. So pretty, I think, easy for people to imagine this, these containers that are on the trains moving to the ships. This is the power unit. So here you have the pistons, the water, and then you can imagine, for 10 hours of storage, 1/3 of this container that you can put on the side or underneath the container in terms of volume. So the footprint can be the footprint of a 40-foot container and a little bit, one container and 1/3 higher for the storage.
Smaller than I would have imagined, to be honest.
Yes. And we are going to, basically how we're going to do it, we're going to first do it in the lab, and then we're going to deploy at a customer location and validate in real conditions.
Cool. Exciting. I had one more question also about the heat management.
Yes.
How do you guys actually store the heat to be reused at a later point?
Yeah, so this is the core of our technology. We have this architecture that is the liquid piston, and inside it, we have our proprietary heat exchanger. And what it does basically is, the main goal is to keep the temperature throughout the system as constant as possible. So we're never going to reach high temperatures. We're going to be, as the water rises and the temperature increases, we're going to constantly extract and transfer the heat from the air to the water, and then we store heat as in the water. So a thermal storage in water, but this is not the potential energy. So when we expand the air, we transfer back this heat from the water back to the air and not letting it free. So the core is this architecture with the liquid piston with our proprietary heat exchanger inside it.
Cool. So there's no weird phase change tanks or anything like that. It's just you're keeping the heat in the water and putting it back into the air at the decompression stage.
Yes, exactly.
One of the things when I was reading up about this, which I read as a payback or a trade-off, is of course the reaction time, I guess. Does it take a while for heat to transfer from air to water and back again? And does this affect the sort of use case which you've laid out? Because of course everyone knows with lithium-ion batteries it's instantaneous.
Yes.
And that's why they're so great for short term.
Correct.
So does that give you guys a little bit of a different niche?
Yeah, so we are a mechanical system, which means it has ramp up and ramp down. But so we won't be targeting the millisecond immediate response, but we take just a few minutes to be at full power. So we can start within 1 minute, less than a minute, and then ramp up to full power in a couple of minutes. So the immediate response, we can leave it for superconductors, flywheel, or lithium batteries, and then we can very shortly after take it from there, which is also good because one core advantage that we have that we can offer to the grid is inertia. So there is an issue that if everything switches on and off, one switches off, everybody switches off, which seems to be what happened in Spain a year ago. So we will be able to provide this ramp up and ramp down. And actually we see this as a growing need, and in Spain is already required in order to offer something to the grid. You need to provide inertia. And this is, Spain is a market that is ahead in terms of integration of renewables. And we are seeing that this is going to be eventually coming to all the markets.
I feel like I recall reading something about flywheels being rolled out in Spain to also address this issue, this inertia issue.
Yes.
Could you tell me a little bit more about materials, what materials you're using, and why materials are important to your solution?
Yeah, sure. So this is a very interesting aspect of our technology because we are using steel, water, and air, and we are completely free from critical materials, and also a very established supply chain. We don't need complex supply chains like critical materials coming from one continent, moving to another, to then come to Europe. We can be basically tier one within your continent, if not your country, and this enables also a very sovereign solution and enables you to have also energy security for your own territory.
This is an interesting bridge into more, I think, the financial side of this conversation, which is that I hear a lot more and more that energy independence is becoming a bigger selling point than climate tech itself, or than, shall we say, the renewable approach or the green label.
Mm-hmm.
Are you guys finding the same thing in your experience with raising money and with talking about your product, that energy resilience is becoming an important topic?
Yeah, so this is super interesting because when we started around 2 years ago, a bit shorter than 2 years, to talk to customers, basically we see a very strong shift in that, energy resilience, energy security was somehow part of our values, but it has completely changed to more important. So we see a lot more interest, especially after some change in politics in the last 2 years. We see that it completely became so much more relevant, and there is a lot more interest in that. And being independent.
Do you think people are also becoming more open to being a little more lenient on unit economics or on levelized costs of whatever it is, and saying, okay, we don't mind paying a little bit more if it's going to give us independence? Is that the case as well, or is that a fairy tale land?
I think cost is always going to be the key, and that's part of the reason why we believe our solution is good, because we have run a cost analysis, and our levelized cost based on studies that we've seen and where we are looking at the cost that we're going to have, we reach a very attractive levelized cost for long durations and large capacity. So cost, I think, it's always going to be important. I think it might change if something very uncomfortable happens, that you will be able to you won't care about that because you want your energy security and sovereignty. But I think until it's a super emergency, cost is going to be a driver. So it is important, but we run our analysis and we come to a very interesting levelized cost of electricity.
Okay. How are you finding the process of raising money and scoping for these clients and these projects which you're looking at the level you are of de-risking? So you've done this lab scale experiment, you're building prototypes. What does this whole ecosystem look like for you right now? Is it really difficult? Are people really on board with this idea of funding these sorts of technologies? How are you experiencing it?
Yeah. So last year we did a small round with angels and our venture builder program. And we raised money just enough to reach the targets that we had set ourselves and prepare for the next fundraising. Now we are just starting, and we see that there is a lot of interest in energy, especially grid scale. And that's super positive. The hard thing is we're building a hardware. So there is a lot more interest in software solutions overall. So it's not that there is not, it's just there is a reduced number of investors who are focused on hardware solutions, because the cycles are longer than software. So you need patient money and people that really understand that hardware takes a little bit longer time. So that doesn't mean that there is not money available. It's just perhaps, it's a longer process in terms of finding the right investors. But we are in conversation with interesting investors that understand that and diving deeper into the technology.
Yeah. Let's just bring up what we were talking about off camera a bit earlier as well, which is there's such a fascinating puzzle here of difficult technology to explain, difficult money concepts to grasp. There's this real human element to this entire ecosystem, which requires a lot of cross-discipline knowledge. How are you and your team thinking about this specialist versus generalist approach to different topics?
Yeah, so I think that's where comes one strength of our team. We have generalists and we have very focused on the topic. So, for example, Denis is a experimental physicist and he's super focused on the technology. And Simon has a lot of experience in the finance part, so he's very much focused on that. And my experience also in cooperation and developing products from the conceptual phase and then bringing to the market. We are a very complementary team in being able to bring the message across. We also collectively we have more than 6 years of experience. And it's very interesting to see that in the conversations we have with investors and supporters, like people really appreciate the experiences we have had. And actually, yeah, we've been gaining trust and people are willing to support us, which is very rewarding to
Yeah.
see. And people dedicating their all free time to support us as well.
Yeah. I mean, it's a tough challenge talking about thermodynamics and asking people to write checks. It's a big bridge you have to jump there.
Yes.
I can see you enjoy it as well. So.
Yes, it's a nice experience.
The last bits that I thought we should talk about today is just about optimism and technology. There's so many different bubbles, especially with social media, you can fall into, and little rabbit holes you can go down of extreme optimism, extreme pessimism, the degrowth movement, the techno optimists, tech bro movement, not a movement, I guess, just group. I'd love to get your perspective on how do you feel about technology and money, like this whole venture world as well, and its ability to solve the problems which we have right now.
Yeah, so I'm very optimistic, and also my co-founders, we share that. We believe we're going to be living in a future that we can harness as much as we can from what we have available. So like the starting point was like, why building a nuclear fusion if you have a nuclear fusion happening above our heads every day with the sun? Let's just leverage the wind and the sun that comes out of it. So I personally imagine that we're going to be able to reach 24/7 electricity from renewables and leaving a much lower trace of our living. So I see that there's also like it is a growing number of people that are becoming more aware of that and are working towards it. And of course, always starts with small agents and then becomes adopted by more people. And it's coming also from politics. There is a lot more pressure to integrate more renewables and reduce emissions. So it's kind of converging, and it's we are, I think, right on the right time bringing this technology and solving a solution that is highly needed.
Wow. And what would be your best case outcome for how you think humanity is thinking about using and dealing with energy, say 50 years from now? Do you have a dream picture which you guys have a chat amongst your team, which you painted for yourselves?
Yeah, so we imagine that our solution is the solution for long duration energy storage.
Only compressed air storage.
No, I think it's a portfolio of solutions, right? We're gonna there is gonna be case by case that where some things work best, and for example, us combined with short-term duration is a solution, and then very, very long durations, other technologies. But I think one could not imagine before solar and wind were developed that it would grow so fast and at such a scale. And now we see it's became super deployed everywhere, and we see more and more renewables. And the future we see is we're going to be able to harness a lot more of what we do today.
I think the last thing I want to ask before we wrap this up is also just, I'm sure you have outlined what your major obstacles are going to be, whether they might be financial or technological or growing a team. Mm-hmm. What are the big things or the big hurdles which you have to jump over in the next couple of years?
Yeah, so of course there is like technology, market, and the political ecosystem. So the long duration energy market is something that is being developed, and we see already movements to that. So in the political level, we need the market to be developed further to enable more revenues coming from the storing and selling electricity, because it brings great value to the grid. Because the more renewables you integrate into the grid, the higher costs you have if you cannot use a lot of these renewables into the grid, because there is peaks of high generation but not high demand. So there's actually a lot of cost that comes with not being able to integrate all that. And then we need, like for the grid scale, we need the utility companies to start looking more into alternative solutions and being more comfortable with that, and perhaps signing off-taker agreements to provide the trust to the markets that this is an interesting technology. We are, if you reach that solution, we can integrate and use that for our own portfolio. And then, of course, developing the technology, there is this challenge. We are developing a new technology, and we need resources. We need more people working with us to do that.
You need welders, you need metal workers, you need pump specialists. Yeah.
Yeah, so that's part of the reason why we are fundraising to increase our team. And it's like the holy grail of the different players and bringing that together. But we are working on them.
Well, it sounds like a lot of fun. Maybe I'll come visit you at the factory one day.
Yes.
When you've got the pilot project running.
Yes, so we have our lab in Grenoble. If you are there, you're welcome to come and visit us.
Cool. Thanks so much for the chat. I wish you guys all the best.
Thank you so much.
And good luck for the rest of your festival day.
Yeah, thank you so much for having us here.
Cool. That was fun.
Good.